addition of two different functions, they are limited to a particular constant or number or level. So if I have limit a plus b to a as x approaches small letter a, limit the two functions a plus b. So I can as well write it as limit x to a or a plus limit x to b, x to a for function b. That is the meaning. So that means it is distributive. The operation is distributive. If I have limit x to a minus b, it's the same as writing it as limit x to a minus limit x to a b. I'm just sharing it. Finish. If you had limit x to a for a times b, it can also be written as limit x to a for a times limit x to a for b.
Anytime you're in red planet,
mute your mic, please. Mute your mic. So the last one now, we have more though. Limit x to a for division, that's the quotient. Limit of the quotient is also quotient of the limit. So we have a divided by limit x to a, we have b. So what we mean here is that the limit of sum is the same as the sum of limit. That's the first theorem. Limit of a difference is the same as the difference of the limit. Limit of a product is the same as the product of the two limits. While limit of a quotient is the same as the quotient of limit. And note this theorem also, that limit of any constant, a constant that doesn't have x, like limit 5, limit x to 3 or 5, then the answer is still going to be 5 because it is ordinary constant. So a number that doesn't have any variable, the limit is still going to give that number. Let me give an example that looks exactly that way. Okay, let's give an example that will involve all this that we just did now. Here is the example. Limit x to 5 in this. I have x squared plus 3x, x cubed plus 3x squared minus 9x plus 7 over 4x squared minus 6x. So you can as well use the theorems and split all these things up. This is a polynomial at the numerator, a polynomial at the denominator. You can split them up. Let's see. That is limit x as it approaches 5 or x cubed plus limit x as it approaches 5 or 3x squared minus limit x as it approaches 5 for 9x plus limit x as it approaches 5 for 7 all over limit. You know, here now we've used sum of limits. We've used difference of limit. Now we want to use quotient of limit. So limit 4x squared as x approaches 5 minus limit 6x as x approaches 5. We all know what limit means before. So to limit x cubed, for those of you that believe doing it straight away might be hard for you, this is a split version for you, a simpler version. We've cracked it into fragments. So you just do them small. So limit x cubed as x approaches 5. So we're using the 5 to represent x. That is 5 cubed plus limit x to 5 for 3x squared. That is 3 times 5 squared minus 9x. That is 9 times 5 plus limit 7. So it's still going to be 7 because it is a constant. That is the fifth theorem I did. And for this one, limit 4x squared as x approaches 5. So that is going to be 4 times 5 squared minus limit 6x as x approaches 5. That is 6 times 5. One 125, you can do it your calculator. 5 cubed gives 125 plus 3 times 5 squared, that is 25 itself, minus 9 times 5 is 45 plus 7 all over 4 times 5 squared, that is 25 minus 6 times 5, that is 30. So let's continue over here. We have 125 plus 3 times 25, that is 75 minus 45 plus 7. So over 4 times 25, that is 100 minus 30. So here now we have 125 plus 75 minus 45 plus 7. That should give me 162. So 162 over 100 minus 30, that is going to give me 70. So here I can also have it as 81 over 35. So therefore, the value of the limit of this polynomial against this, so this quotient, so basically, this quotient is going to give me 81 over 35. So we just applied all the laws we mentioned now. So you can go through it and ask any question. Okay.
No, it's 162. You are right. It's 162.
Please, guys, hope we are gaining something from this. Hope we're understanding it. Are you guys getting it?
So set the camera very well.
Yes, Any question? What's your question? Please speak out, please.
Excuse me, bro. Please, I just joined. I'm really sorry about that. Can you just?
You are going to watch the video. Oh, you just joined. Do you expect me to come back? No, it's not possible. I'm sorry. Let's watch that. Yes. Hello, are we done with it? Are we continue? Or do we still have some questions?
Let's continue.
Can we?
Okay. Okay, let's say now We're working on limits, right? All these ones we just did now. We used one theorem. We call it replacement theorem. Replacement theorem. What do we mean by replacement? We just took 5 to represent x squared. So there are some cases that the replacement theorem will not work. Mr. Tochukwu, I'm sorry, I can't go back, but because you are someone I know very well in this class, and good to see, just try to look at this. Let's say you are given is to limit x to 2 in this thing, 2x cubed plus 5x minus 2 over 2x. So you can just go straight away and say this. You are using the replacement theorem. So that's going to be used to represent x. You are replacing x by 2. That is what we mean by replacement. So that's 2 times x is 2 raised to power 3 plus 5 times x is what? 2 minus 2 over 2 times x is what? 2. Here now we have 2 times 2 raised to power 3 is 8 plus 5 times 2, 10 minus 2 over 2 times 2, that is 4. So here now we have 2 times 8, that is 16 plus 10 minus 2 over 4. So then we have 16 plus 10, 26 minus 2, that's 24 over 4. Then that is giving us 6. So the value of this limit is going to be 6. So as we just replaced it now, means replacement theorem. So there are some cases that we will be unable to replace anything. It will be so hard. If you want to replace it, your equation will become undefined. What do we mean by undefined? Once you have any equation, it is undefined. When they say anything is divided by 0, believe that that thing is undefined. If they give you 2 over x squared or 2 over x minus 1, and they said if this is undefined, what is x? Just know that the coefficient is 0. That's what they mean by undefined. So x is going to be equal to 1. So I'm talking to those that find it so fast. So then let's take something. Here is limit x to 1 in this quotient. We have x squared minus 1 over x minus 1. Okay, let's say take x 1. Take x 1. Let's say x squared minus 1. I'm just thinking it's too simple. You should start from simple. So let's say this is the question given to you now. Do you know if you come here and use the replacement theorem straight away, you'll be having issues. You'll be having issues. So if you replace it now and say 1 is representing x squared, that is 1 squared minus 1. That gives you 0, right, at the numerator over, though you're having 0 at the numerator doesn't mean anything. You having 0 at the numerator doesn't mean anything. But once you have 0 at the denominator, see, just believe you have a problem already. There is a problem here. So x minus 1. So that will be 1 minus 1. That means it is 0 over 0. The answer is infinity. The limit does not exist. So anything over 0 is undefined. So because of that, we're going to use the factorization theorem here. What do we mean by that? Factor theorem, rather. Let's go. Limit x to 1. Factorize x squared minus 1. That is what? X minus 1 times x plus 1. That is the difference of squares. Difference of 2 squares. I personally explained this, I think, last semester. Difference of 2 squared over x minus 1 that is here. You can see now that x minus 1 cancels this x minus 1. What are we left with? We are left with limit x to 1 for x plus 1. So now just do your work. This is going to replace x. 1 plus 1. That is going to give us 2. So the answer could be gotten this way. But if you use the replacement theorem here, you will have an undefined process or function. But here now it is defined. We won't have the answer. So we'll still take another one. So this is another one. Let's say we have limit x to 5. I have x squared minus 25 over. Okay, let me think of something harder. Minus 2 minus 6. So minus 2. Let's say x minus 2. Let me write it as a polynomial already. So x squared minus 8x plus 12 over x plus 6. So find the limit of this as it approaches. See now, as x approaches 6. Everyone, look at the question we have on the board very well. Look at the question we have on the board very well. You see what it says? I want you to listen very well. Be attentive to this. Don't let us waste our night on this. I mean, without getting anything. I'm really feeling very, very sleepy. So it is necessary to have it that. So x to 6. We are limiting x as it approaches 6. That is, we are limiting x to 6 for this thing. Do you believe if I use 6 squared or replacement theorem now, 6 squared minus 8 times 6 plus 12, it still goes over. Once I say 6 minus 6, that is 0. The denominator becomes 0, and that renders it undefined. We should not do something like that. So let's move well by using the factor theorem first. Let's factorize this thing. Factorize x squared minus 8x plus 12. To factorize that, I know there are many books here. So please, I'm waiting for the factors. Factorize it, guys. I'm waiting for the answer. Rudy is here. Joy, Mr. Charles is here. Nick Smith is there. Mr. Raphael. Of you. Amina, Jeff. So please, I'm expecting you guys and some other people that I didn't even mention their names. So waiting for you guys. Factorize it and just tell us the factors. X plus what and x plus what, or x minus what and x minus what, or x minus what and x. So I'm expecting the factor from x. Factorize x squared minus 8x plus 12.
X minus 6, x minus 2.
Perfect. So that's very perfect. We have x minus 6 times we just solve it. It's not an equation, bro, but it's an expression. It doesn't have equality sign, so it's not an equation. This is an algebraic expression. You can just multiply two things to give you 12. Two things that you multiply together to give you plus 12. And when you add them together, minus 8. So he believed if you had minus 6, x minus 2x, that's minus 6 and minus 2, plus 12. Just group it. X is common here. You have x minus 6. Minus 2 is common here, right? And x minus 6. What is in this place must be the same as what is in this place. So you have x minus 2, that is x minus 2 and x minus 6. Wasting much time on the things that are now applicable. So because we have a lot to cover. So if I keep doing that, we will not get to anywhere. That's why I try to stop me these days. X minus 6. So now x minus 6 cancels x minus 6 in this thing. Now we can work with our issues. So limit x to 6 now. Then we are going to have x minus 2. That is what? 6 minus 2. So we can come here and say x is limited to 6. Limited to 6. As x approaches 6, that is 6 minus 2. Therefore, the answer is 4. But if I use the replacement theorem straight away, I'm only going to have 0 under. That is 25. So please, did you understand this work? If you understood it very well, please. Please, did you understand it?
Explain it a bit again. Explain it a bit.
Sorry, Ali. A question, please. Question, please.
Okay. I can hear you.
Sorry. So how do we know if to use replacement theorem or the second one? Because if the replacement theorem sometimes will give us.
Now, how do you know? You can just take a good look at it. That is, go through it. If it's a replacement theorem, if the replacement theorem could not be used, then the number they are asking you to limit it to, if it's positive, then the same under, just let me think of it as a better way to explain it now. See, you are given x plus minus 2, x minus 6 over x minus 6, and they limited x to 6. We can just try it straight away, replacement theorem. We can as well try it first. That is going to be replacement theorem. That's x6 minus 2, right? Times 6 minus 6. That is 0. It doesn't even affect that one. Over, this is now 6 minus 6. So, this is 6 minus 2, 4 times 6 minus 6, 0, over 6 minus 6, 0. So once you get 0 from this thing, quickly go back and use the factor method because the thing is undefined. There are no cases like this. That is the meaning. So if you think it's not so easy for you to use your eye to go through it fast, then try to solve it somewhere and see, do you have 0 as the denominator? Once you have 0 as the denominator, just believe me, you can't use this replacement theorem. Can't use the replacement theorem. Definitely there should be something that can cut it somewhere. Once you have 0 at the denominator, there should be something that can cut it. So you just have to go through the factorization process. So to get that, what do you use? You can as well use your replacement theorem first. But once you arrive at 0 at the numerator doesn't mean anything. But once you arrive at 0 at the denominator, my God, it's problem. So it is not part of it then. You understand? Anything over 0 is undefined. So that's why that's what will lead you to using the factor theorem. Mr. Ibe, you're not muting your mind. What did you
Andrew, talk now. I thought
you are thinking
when the numerator is also
when the numerator
I think it will be undefined too. Hello, can you hear me?
I can hear you. Okay. If the numerator is 0, it's actually
if the numerator also is 0,
it's like saying
defined too.
You know something?
No, I think it's
one thing that renders
if the sum
when
of
we
the
say an
numerator.
equation is undefined, I've understood this question. When we say an equation is undefined, definitely the numerator is equal to 0. It doesn't even concern the numerator. But coincidentally, the numerator too might be equal to 0. And in some cases, it might not be equal to 0. Look at what I have here. X minus 2 over 0. This is definitely undefined. If I now have 0 over 0, 2, I can say it is undefined. So anything divided by 0 actually gives us infinity. It gives infinity. So you know when they say something is it's not undefined. It is 0. Do you understand me?
But
0
it is not
divided by 5
undefined.
is 0. Well, that's what I'm telling you, that this one is not undefined.
Okay.
Once you say,
That's what I
okay,
want to know.
5 divided but 0 divided by 5 is 0. Anything divided by 0 is undefined. But 0 divided by something too. Or any question?
No.
All right. So any other person, please? Any other question? Any question, please? Okay. Let's take about 1 or 2 more. Please. When we treat okay, this is something now. You have limit x to infinity. For this thing, let's say I have how will I form a question for this one now? Oh, and I used some notebooks to solve some stuff like this. I couldn't find it. Maybe you should give me a minute. Just tell me a minute. I hope I'm going to find it. It's not there. Like I had the questions in it. I solved so many questions on that limit that time. Inside that book. I can't find the book now. Oh, okay. I've remembered the book. Go back. All right. I think I found it. Great. So everyone, you have to be very attentive here. You have to be very attentive. So it involves some tricks too, some mathematical tricks too. So you have to be very attentive. Here is the question. It says limit x to infinity of 3x cubed plus 2x squared plus x plus 1 all over x cubed plus 2x plus 5 plus 2x plus 5. So now we are taking the limit to infinity. What do we do to achieve something like this? When we are taking limits to infinity, I want you to note one important stuff. Try to do your workings. Try workings until you have 1 over x. Because limit of 1 over x to infinity is going to be 0. There is a reason for that, which I won't be explaining tonight. Another time. So, try to do your workings until you achieve 1 over x. So, let's go about that. First, divide the numerator through by x cubed, or multiply the numerator through by x cubed. Let's bring x cubed out. Let's bring x cubed out. It is easier now. X cubed. It's x cubed we are bringing out, not x. So look at it. We have limit x to infinity. So if 3 is here, let me bring x cubed. Let's say, I'm doing it as if x cubed is common to everything here at the top. X cubed is common to everything downward too. So I'll be able to cancel x cubed out. So I will have a reciprocal of x multiplied by a constant throughout. So x cubed in 3x cubed now, it is going to remain 3 here. Please, do you get what I just did here? It is going to remain 3. X cubed is out already. Please, if you got that, let me see. Perfect. So, as for this one now, you should note very well that you have 2x squared. Now, divided by x cubed, definitely is going to remain 1x under. So, 2 over x. Hope I didn't confuse anyone with what I just did now too. Plus...
You did, though, please.
I did. All right. I did confuse someone. No problem. Have a look. Once I have something outside, I can as well divide everything inside it by that. I'll be able to get what would be inside. 3x cubed divided by x cubed. Divided by x cubed. It remains 3. That's why the 3 is here. Now, 2x squared divided by x cubed. Look at it. 2x squared divided by x cubed. X cubed for x squared. So it remains 1x under, right? Because 2x squared is 2x times x. Over x cubed is x times x times x. So x times x cancels x times x. It remains 2 over x. So I will write the 2 over x here. Plus, this is x divided by x cubed. X over x cubed. I have 1 x here, 1 x here, x squared. So 1 over x squared. Plus, this one cannot even be possible at all. 1 divided by x cubed. You will see that if you open this bracket, you are going to get what is here exactly back. So now do that same thing to the denominator. Do that same thing to the denominator. X cubed in x cubed, that is 1. Plus x cubed in 2x, that is 1 over x squared. Plus x cubed in 5, that is 5. Okay, this one is 2 over x squared. That is 5 over x cubed. I think I'll have to explain this one again. I think I'll have to explain it again. I don't know if everybody got it. So listen again, please. I brought this x cubed out. Now 3 plus, that is how to do it. Once you are taking it to infinity, just take the highest power. The highest power is 3, x cubed. So take that x cubed out. Now take the remaining factor. How is it common to everything in there? So everything in the bracket. So you have x cubed times 3, that is 3x cubed. X cubed times 3 over x. So you can as well do it. X divided by the x cubed, you will have 1 divided by x cubed. you have 1 over x cubed. So x cubed divided by x cubed, you have 1. 2x divided by x cubed, you have 2 over x squared. Plus 5 divided by x cubed, that is 5 over x cubed. No, nothing will cancel anything. So here now we are limiting x to infinity. You can see that this x cube cancels this x cube already, right? So we have left 3 plus 2 over x plus 1 over x squared plus 1 over x cubed. Two over x squared cubed. So now everywhere, note that limit to infinity for 1 over x is always 0. Note this theorem I just wrote here. It is very important. Have you noted it? Now let's go. This is now going to be, let's use the distribution theorem for it. We have limit x to infinity for 3 plus, this is 2 constant, right? 2 limit x to infinity for 1 over x is remaining here, plus limit x to infinity for 1 over x squared, this is squared, plus limit x to infinity for 1 over x cubed, all over. So for this one, limit x to infinity for 1, this one, plus 2 is here, right? You can bring the 2 forward. 2 limit x to infinity for 1 over x squared, plus limit 5 is here, so bring the 5 before limit. 5 limit x to infinity for 1 over x cubed. That is established. Now, limit x to infinity for 3. Is this the same as 3? So we have 3 here. Plus 2 limit x to infinity for 1 over x is 0. That is 2 times 0. Plus limit x to infinity for 1 over x squared is also 0. Since we have 1 over x to be 0. So limit 1 to infinity, limit x to infinity for 1 over x times limit x to infinity for 1 over x is also going to be 0. That is 1 over x squared. So 0 for cube 2, 0. Do you understand? So now over, we have limit x to infinity for 1. That is 1. 2 limit x to infinity for x, 1 over x squared. That is going to be 2 times 1 over x squared, 0. Plus 5 times limit x to infinity for 1 over x cubed, 0 also. So here now we have 3 plus 0 plus 0 plus 0 over 1 plus 0 plus 0. The answer is 3 over 1, which is 3. I hope I can. I believe there will be questions.
We are confused. The 3 is too much, it's too long.
Is that my fault?
It's very long.
Please pay attention. Hey. I haven't done some stupid thing. I solved the question for someone not long ago. It is one of the it is just a question. I think I spent over 1.5 pages in maths. It happened in physics too. I spent over 2 pages in physics to solve the question. Maybe 3 weeks or 4 weeks ago. They were just 1 mark, as you know, TMA, 1 mark. Awesome. No message. Miss Joy, do you have any question?
My question is, does it mean that no matter the number of power of x, that is, maybe it's x raised to power 3 or 4, like to always be 0?
Yes. Yes. So far, it is reciprocal of it. It is just due to one of the theorems of one of the rules of limit. You know, 1 over x is limit 1 over x as x approaches infinity. That one is 0. You know, we mentioned that one is 0. So
Yes.
if I now have that one, if I now have 1 over x raised to power 100 self, it is still going to be 0. I can put it this way for, so like having infinity number like 1 million, take it to 1,000, take it stuff like that. But just look at this technical method. X raised to power 100 is x times x times x times x times x. So 1 over x raised to power 100 is 1 over x times 1 over x times 1 over x. So since 1 over x give us 0, then 0 times another 0, another is 0. So I hope you should understand that way. Great. So
Thank you so much.
You're welcome. 3x cubed plus 2x squared plus x plus 1 over x cubed plus 2x plus 5. So we bring x cubed out because it has the highest power. So by that, we are going to be having values that will have x under them, which will make our replacement theorem work. So x cubed is brought out. X cubed in 3x cubed, we have 3 remaining. X cubed in 2x squared, we have 2 over x as a remainder. X cubed in x, it's remaining 1 over x squared. X cubed in 1, that is 1 divided by x cubed, that is 1 divided by x. Sorry, here now, x cubed under also, x cubed in x cubed, that is 1. X cubed in 2x, that is 2x over x cubed, that is 2 over x squared, plus x cubed in 5, that is 5 divided by x cubed. Ms. Abigail, your question first before I go further.
Okay, thank you, Ali. Well done. Please, then you are talking about bringing out this s cube because it's the highest power. Is it that any highest power are the ones you will bring out to use to multiply the rest?
So because since it has the highest power, by the time I bring it out, I'll be having fractions. So it's because of the fractions I'll be able to take this infinity to 0 here. So that is it. You bring it out. That is the law. Use the one that has the highest power. You can as well use another method. I think it was around maybe February. I saw Mazi use another method, and I like the method. So it was very good. I like the method. So it's the method of you just evaluating. It's the method of you evaluating. So like saying, if you can use 1,000, I don't want to do it here. I can take it in another class because there is another thing I want to use it to explain. And today I didn't want to stress myself up to this level. So I will explain that thing I mentioned. I will explain it in the next class today. So it's another way of taking things to infinity also. It's even very simple. We'll be using them. And it goes aligned with the L'Hopital's rule too. Okay. So that's it. That's what you're bringing out. Now 3 is here plus 2 over x, everything here, divided by what we have here too. So you know what we did here? We just distributed the limit x to infinity for everything here. We distributed it for everything here. The third theorem says that limit of a quotient is the same as the quotient of limit. That is it. So that is that. By that we got all this. So limit 3 is a constant 3. Limit 2 times 1 over x squared as x approaches 0. And x approaches infinity. So we know that is 0. So that's why these zeros are here. And at the end of the day, we arrived at 3 as our final answer. So let me see. I think I have another question here that's going to make our day. So, sorry, make our night. Let's run this far. So, all right. This question says, wow, there are so many questions. The notebook, I use the notebook to solve some questions. Limit x to infinity for x squared plus 3x plus 2 over x squared minus 2x plus 7. I know there are very smart people here. I mean, extremely smart people. That they will be able to answer this thing. They will be able to solve these things now. I have some people that I believe in them to that level. They can solve this thing now, even without just one explanation. But let's do it together first. So what do we do? Because x squared is the one with the highest value, let's bring it out. We have limit x to infinity, x squared, bring it out. What is left here? 1 plus, so x squared, this is what we are doing, x squared divided by the x squared, 1. So 3x divided by x squared, x cancel squared. So we have 3 over x plus 2 divided by x squared, that is 2 over x squared. All over x squared, bring it out also. X squared divided by x squared is 1 minus 2x divided by x squared. X cancels the square. So we have 2 over x plus 7 divided by x squared. 7 over x squared. So if you have the time, sit down by yourself and see that you are dividing. The answer is, what did she say? 1. Wow, that's very great, Joy. I hope we arrive at that answer. Okay, let me see the view. Wow, it is 1 I got here. Perfect. Perfect then. So we are going to arrive at the 1 together. So now the x squared has been cancelled by the other x squared. So now let's just use the distribution first. We have limit x to infinity for 1 plus 3 limit x to infinity for 1 over x plus 2 limit x to infinity for 1 over x squared over limit x to infinity for 1 minus 2 limit x to infinity for 1 over x plus 7 limit x to infinity for 1 over x squared. Let's go. Limit x to infinity for 1 is 1. I said limit of any constant plus 3 times limit x to infinity for 1 over x, 0, plus 2 times limit x to infinity for 1 over x squared, 0, over limit x to infinity for 1, 1, minus 2 times limit x to infinity for 1 over x, 0, plus, if I have 100, if I said, infinity means I can use any value to infinity. Let me use 1. 1 divided by 1, 1. Now let's use 10. 1 divided by 10, 0.1. 1 divided by 100, 0.01. 1 divided by 1,000, 0.001. 1 divided by 10,000, 0.0001. 1 divided by 100,000, 0.00001. 1 divided by 1 million, 0.000001. So 1 divided by 10 million. So like that, you can see that as that 0 are becoming much, it's becoming smaller. And as a number is becoming smaller, it is approaching 0. So at the end of the day, it will reach 0. That is what I'm trying to say before. I didn't want to explain it here. So I just give a tip now. I gave a tip now for those of you that might understand it. So I'll explain it better in another class because I'll be using it for some things that will using this method. So plus, but that is the logic behind infinity giving you 0. That is the logic. Very simple. That's what I just explained now. So plus 7 times infinity 1 over x squared, limit x to infinity. That's 0. So here now we have 1 plus 3 times 0, 0, 2 times 0, 0, over 1 minus 2 times 0, 0, 7 times 0, 0. Here we have 1 over 1. Therefore, we have 1 as our final answer. Is there another person that has done it before I finished it? I enjoyed it. Another person? Wow, that's great. Body. Okay. That is that as for that. I have so many questions here, my God. Wow. So I think I will stop questions under limits that involves infinity here. Let me see if I can see one. So these are what I will treat tomorrow. If I can see one more about that infinity. So everyone, there is this first principle law. Who is going to solve the first principle law for me? Let me see if I'm also trying to use that exact question to see if I can remember how that thing comes. F of x is equal to okay, I have the h of x now. H of x is equal to so h prime of x equals h plus, I don't remember. No, h plus I bet now I don't use my on our time. And I can remember. I'm not even ready to stress my brain now. I can't stress my brain now, and it's something I can remember. I just need to settle the brain again some stuff. But forget it. Forget it. My brain is not ready to be stressed at all. At all. So that's that as per taking infinity and the likes. Let's see if there is something else we can take a look at.
And you read. And you read.
Okay, Prodigy, anything to say?
Can you help us with limiting x to 0?
No, pass with that, bro. See, limit x to 0 here. Or do you have a question there we can treat? Limit x to 0, that is 2 times 0 squared plus 5 times 0 minus 9. 0 minus 0 minus 9. The answer is minus 9. Bro, it's just like limiting x to any fucking thing. Let me see if I'm going to see the question here. Yeah,
let me give you a question.
Very good.
Though I understand, let me give you a question.
Yeah, go ahead.
Limit x to 0, square root of x minus 1.
Limit x to 0.
0. Square root of
x minus 1.
1 minus 1. X plus 1 minus 1.
Very good. This one is involving. So everyone listen, this is something we can take. Square root of x plus 1 minus 1. Written like this.
Over x, yeah.
Over
x.
Over x. Everyone, I want you to note what is given here. See thunder. What is it called? Storm, everything. Maybe I say I won't sleep. So square root of x plus 1 minus 1 over x. The first thing you should note is that your question is given this way. Once you take your square roots to be covering this thing, first problem will come. This is how you are given your question. The square root covers x plus 1 minus 1 over x, limiting x to 0. You know how naughty is going to be if you limit x to 0 by replacement now. It will be undefined straight away. There is nothing you can do to that one. So what do you do in that essence? You come here. The first thing, since you have it in short form, you multiply by the conjugate. That is, you rationalize. So multiplying by the conjugate of this numerator, the conjugate of square root of x plus 1 is going to be square root of x minus 1. So the conjugate of square root of x plus 1 minus 1 is going to be square root of x plus 1 plus 1. That is what I mean by the conjugate. The sign changes. The sign between the object inside the sort form, inside the bracket, and the other object that's not in the bracket. The sign between them changes to the opposite. Please, did you get that? So I'm going to work with the conjugate now. Multiply the numerator by the conjugate and multiply the denominator by the conjugate. Let's go, boss. We have limit x to 0 or x plus 1 minus 1 times limit x to 0 times x plus 1 plus 1. Don't forget the conjugate over this x times the conjugate again, x plus 1 plus 1. You are multiplying through by the conjugate. So let's solve this one. At the top here, I don't want to waste our time, and most especially my own time. You are going to have x plus 1 minus 1 at the top. It won't be polite that way. That's what you are going to have. So, but let me be nice. Look at it, everyone. Look at it. You multiply square root of, if they are in brackets, use this square root of x plus 1, multiply it again.
The sign, the bracket.
No. The sign under the bracket is not affected at all. That is what you should note. That's a very great question. It's not affected. The one inside the bracket, you treat the both of them as an identity, as one value. This is one radical, one radical. That is what we are doing. So you can see that I'm multiplying the both of them together against the both of them here together. So square root of x plus 1 times square root of x plus 1. That becomes square root of x plus 1 squared. So that is going to give me x plus 1. Because x plus 1, square root of x plus 1 will cancel square. So square cancels square root. It's going to remain the ordinary x plus 1. So now square root of x plus 1 times this one. That is plus square root of x plus 1. Minus 1 times square root of x plus 1. That is minus square root of x plus 1. Then 1 times 1. That is plus 1. So you can see that I have plus square root of x plus 1 minus square root of x plus 1. They are the same value. So that gives 0. This one minus this one gives 0, right? So over x times square root of x plus 1. That is x root x plus 1 plus x times 1. That is x. So here now I have x plus 1 plus this 1. What is here? Are you getting it? Over x. I hope I'm answering your question. All right. Over x square root of x plus 1 plus x. Okay, this is minus 1. Yeah, I'm saying that, why is it not as I predicted? The one I did without solving it was minus 1. So this is supposed to be minus 1 times minus 1. That is minus 1. So that gives 0 to minus 1 plus 1 plus 1 minus 1, 0. So here now we have x over x root x plus 1 plus x. Note what we are doing. X over x is common here, right? Bring the x out. What do you have left? Square root of x plus 1 plus 1. I should have passed through this process before, but because I thought it was plus 1 before. So x cancels x. What do I have left? 1 at the top. 1 over square root of x plus 1 plus 1. Don't forget your limit. Limit x to 0. So now come. This is what you have. You have limit x to 0. Wow. I hope that's what I'm going to get to. Joy, I think that's right. It might not be and it might be. But your answer is not the final answer. Joy, rationalize the denominator. They don't leave sort as rationalize it. That's going to be root 2 over 2. So we have 1 over square root of x plus 1 plus 1. Now take x to the 0. You can take x to the 0 without any problem now. The replacement theorem. So square root of x plus 1 is square root of 0 plus 1 plus 1 plus 1. So 1 over square root of 1. That is 1 plus this 1. Joy, take a good look at this. Note where the mistake lies now. I think you extended your bracket later, your sort. Your square root, you extended it. Don't extend it. So 1 over square root of 1 is 1 plus this 1. So we have 1 over 2 as the final answer. What did you do? Did that answer your question? Great. So every other person, please, if you have any question concerning this, I'm entertaining your question. Any question? All right, let's treat it as no question. Let's treat it as no question. And then, okay, I think we should call it a day. I think we should call it a day, everyone. So that's that as per that. I think we were able to take 1 or 2 things. I wish everyone the best. So do have a nice time. If you think you have some issues with these stuffs, please don't hesitate to text Mr. Andrew. I can recommend some people to you here. Hey, Naomi, what's your question?